Okay, so the ring that we did in Rhino, this fella that I posted, just to give everyone an idea of how that works between the CAD and getting it done in on the mill, is really after you're done with your CAD, there's a few rules depending on your mill and what sort of fixturing system you're using as to what geometry needs to be added. In our case, we're adding a little pipe, a couple of supports into the hub, and an indexing cone. Alright. Once you've done that, you export some STLs into a folder, and it goes something like this: file, load geometry. We're going to write some paths. Okay, and I'm going to record this a little slower and a little bit better because my wife's going to use it as well. So I'm going to use the flips STL. So this is what you just saw in Rhino now. It's the geometry used for cutting the flip sections of this, so that you can use it as a reference. So I'm not going to get too much into explaining because this is primarily for my wife. There's the indexing cone. Here's a couple of supports around it. They're the supports holding into the hub. Alright, so I think most people with existing mills understand how that works. But anyway, let's onwards. Alright, so the first thing we need to do is we need to set up a couple of ground rules about how we're going to cut. So I'm going to go into the part section of this operation, and basically there's a few things there. I'm telling it what kind of machine I'm using and what the name of the part is. This is going to be side A of this part. I'm going to be using my own machine. I'm not using the rotary axis. I don't need to transform the part at all. I don't need to create supports. For my segment, when you're using custom curves in Desperado, it can be full of shit and give you a whole lot of errors that nobody understands. So when I set custom, I normally double these numbers up just to give myself some breathing room. So if that's minus 13, I'm going to go minus 20 to 20 at least, and same over here, 20 by 20, just so that I don't get any of segment errors that it loves to throw at you. So I'm going to go from minus 3.5 to 3.5. I just add a little bit of leeway around everything just to make me a happy fella. All right. Then the actual operation that's going to run over here, we can set a segment that's more confined. We did that by drawing a curve in Rhino. I'll show you the curve in Rhino. The curve in Rhino is this guy, exported as a DXF. Okay, so we're going to set the cutter we want. So these are all cutters. I can't teach you everything about milling in one little video, but anyway, so these little cutters, all different cutters you can use on your mill. In this case, I'm going to be using the tapered ball end mill. My step over for this is going to be there, and the step along is going to be there. And this is just, the smaller these numbers become, the better the surface finishes. Okay, I'll set my feed rate at 400. The reason I use 400 because we can multiply by a factor of x3 in Mac, which means we can run it at 800, 1200. And generally I think it wouldn't run faster than 800 anyway. So the next part is strategy, and this is just going to really, what these things mean is how you're going to cut this. Those lines, so you're going to cut it in a raster motion like that. Crosswise is going to cut in a raster this way, then it's going to cut in a raster that way. Block is going to work its way around in a square. Circular is going to work its way around in a circle. Radial, it's going to cut across like this. So depending on the type of geometry you're cutting, this will have some impact. I don't know. To me it's all bullshit. Parallel just works. Okay. Roughing, I don't need to do any roughing for this job. It's reasonably flat. Segment, okay, so in this case I want a custom segment because I don't want to be cut until Kingdom Come. So I'm going to bring that curve in, which is that guy, and I'm going to go okay. Alright, so the only other thing I'm going to change is I want to cut all the way to minus 3. I only want to cut down to just below my pips. I'm going to set that to minus 0.5, and I'm going to apply that. Okay. So any borders, movement, I don't need to change anything in here. I'm going to leave that on 0. I'm going to click on always stay low. I don't want feed rate plungers to do anything, and I'm just going to go okay. I'm going to write a path, and let's have a look at. So what this is doing is calculating the actual path that the cutter tip is going to travel over the geometry in a raster fashion. Come on, hurry up. Yoo-hoo! Now, while this may seem slow, you have no idea how ungodly slow this is in RhinoCam when it's generating over very high mesh detail. Okay. So really, if you zoom in high enough, you can see that this is the line. It's going to come in this is the line that's coming down, then it's going to cut over there, and it's going to come back. It's going to cut over there, it's going back and forward, back and forward. It's going to work its way over the geometry. Alright, you can kind of see a bit more of the mesh in there. You can see the actual lines that are going to travel back and forward. Alright, so all that work being done once doesn't need to be done again. So what I'm going to do, we're going to cut the other side of this. Alright, so I'm just going to take everything to stay the same, it's just that we're working on the other end. So I'm going to go copy, and I'm going to rename that to side B, which is the back. And the only difference is I need to tell it now that we want to flip the geometry over. Alright, so in transform, over my x-axis I want to rotate the geometry around. So in my x-axis I'm going to rotate it 180 degrees. Okay, I'm going to apply that, and you'll see that my geometry is actually flipped over. So I'm going to go OK over there. The only other thing I've got to change is my segment. Because I've flipped everything over 180 degrees, my segment is reversed as well. It's saying I want to cut from -3.5 to only half, which is wrong. I still want to cut from -0.5 to 3. OK, and apply, and OK, and let's generate that path. Let's have a look, see, and then we'll do the rotary segment. Because I use an indexing bit, I can't just flip this straight up because Desproto doesn't allow me to add geometry into a scene and then remove the geometry from it. So I actually have to run it as two separate files. Okay, I want to finish writing that path. Okay, so the front and the back of this is now written. Everybody's happy. I have to automate some of the operations, so I'm going to go back to side A, and I'm going to say that in the advanced section under settings, I'm going to, before this thing starts, make sure that the A is at 0. Okay, make sure that Z is at 70 mil away from A, just so if any wax is rotating it doesn't hit the machine. After this operation is completed, move Z to 70 mil above the wax, and then move A to our next starting position, which is going to be 180 degrees. Okay, I do want to use chaining. When this is done, I want to cut part number B. So I'm going to go OK, and I'm going to go OK, and then I'm going to check the advanced operations for that. And like I say, before this starts, make sure Z is at 70. Make sure that I'm cutting at 180 degrees, so I want to make sure that my A is at 180 degrees. When I'm done, I want to move Z away to 70 degrees. I want to roll my A back to the top, which is 0 degrees, and OK, and OK. And basically we're ready to write this path. I'm going to write the path to there. Save. Yes, I'm going to get a warning saying that I'm trying to concatenate two paths. I do want to do that. I have planned it. And setting up and pathing the flips has been a 8-minute job. Alright, so we're going to get to the rotary in a section when that's finished writing the path. Trust me, this, if it seems slow to you, you wait till you use some of the other programs. Jesus. Desproto lacks some refinement in many areas. Alright, so I'm going to file and save this. File, save as, flips, save. Yes. Okay, we're about to move on to the rotary segment of this because this is now ready. The flips are cut. Okay, so file, new. Okay, file, load geometry. So what we're going to do now is I had one piece of geometry sent out as a flip and the other piece of geometry correctly oriented as a rotary segment. The reason you have to do this run around is because there's no way for me to remove the indexing pyramid from Desproto. I can't unfortunately add it in and then remove it in between parts. So the first thing you're looking at is I've got a square block around my rotary ring, and the first thing you notice is, alright, so everything is centered, but I've got a square running around my geometry. This is your first warning sign that things are not the way they're supposed to be. We're trying to cut a rotary using an index. An index is square, rotary is round. So we can go to the part, we're going to name it rotary. Whoops, rotary. Okay, and then at this point we do want to use fourth axis stuff, so we're going to click on use rotational axis. You're going to get a warning saying that everything's going to be flipped around. I'm going to say don't show me the warning, and we'll go yes. Okay. The segment we need to cut, I'm going to just go apply and OK. Right. So at the moment it will find the smallest, narrowest margin it can around there. So it's going to try and bring the cutter down if it can, possibly all the way down to here. the way that we're going to cut this is not going to matter because it's not going to go over the edge of the outside. But if the cutter can see through the middle, it will try to go down. So we're going to set a Z bottom to this. In our segment, we're going to go custom, and for Z, it's currently set to 0. We don't want it to go all the way to 0. We want it to go in under the bottom here. I don't know what this finger size is, but that would usually be half of whatever the finger size is. I'm going to go put on 8mm and apply, and let's have a look. I don't know, pretty good to me. Let's put on 8.5. Yeah, I'm just going to go OK and rotate this so I can see what I'm doing. Yeah, that's pretty good. That's pretty good. Alright, so I'm going to go back in there just so we can recap what we were doing. Alright, so just in the segment section, what I've done is I've lifted my Z bottom upwards so that there's a ground plane. In RhinoCam, you'd have to draw this ground plane in. In X and Y, it's already at the maximums of the piece. There's no reason to change that. So essentially, we're pretty much ready to get going. I'm going to go OK. So we need to now set our cutters. We're going to do this in the operations section. And we're going to use the same tapered ball end. I'll reselect that because I went out of the screen, sorry. So the tapered ball end down there. I'm going to set the step over nice and fine. And the feed rate 400. And our strategy is going to be the same as usual, parallel along x-axis. If you leave these two, it'll work the normal way. If you change it to along the x-axis, what's going to happen is it's going to cut around in a circle. Alright. Roughing, we don't want any roughing. Okay, so segment, we don't want any segment. There's nothing we need to change over here. Okay, there's only one thing over here. We're going to go always stay low. We're going to set that on 0. I'm going to set that on 100%. You can, I don't think any of this matters. You can set some defaults for this and go apply. Alright, so under advanced, there's another thing called have a look at your geometry over here. Ambient skipping. None says go all the way to the end of the segment. Alright, so the segment here is the 2 green lines. It's saying cut everything in between the 2 green lines. This one says skip extra ambient, so it will cut everything around. In other words, it will dip down the 2 lines, but it won't cut any further than that. So this gives you a problem that we've seen in some of our jobs where if your flip Z was slightly different to other stuff, you'd actually get ledges or so on along the geometry. What we want is we want to skip total ambient, alright? Which means don't even go down the side, stay only on the top, alright? So I'm going to apply that. I'm going to write the path, and let's have a look at what we got. Okay, so what would you estimate was the amount of time that RhinoCam took to generate this?
2-3 hours.
2 hours, 3 hours. This may take, I don't know, probably 3 minutes, 4 minutes. What I'm going to do is I'm going to pause the video. There's no point for you to sit here while this takes a couple of minutes to do, but I will report on how long it took. It's now at 13 minutes. Okay, so that was 7:33. That was 4 minutes. 4 minutes of pathing time. Sorry, I've got to move that out there. And it's just what it's doing now is just optimizing a little bit of stuff. Alright, so what that's done, you can see now. I'm sorry, I'm showing this to my wife. You can see that it's completely skipped anything that it has to go over.
Yeah.
You with me? It's only going as far as it can see geometry and no further than that. So number one, it saves you a lot of time. Number two, it saves you a lot of wear in your tools. Not that we get a lot of wear, but the most important thing is you don't get any overcut of something that's already been cut. Alright, so that's the rotary path being written, and total user input time 14 minutes. So we're going to write this path now. We're going to write that NC path to here as rotary. Rotary, and save, and I'm going to also save this file out for you. Okay. Okay, so file save as rotary. Maybe the new Desproto, for all I know, they've fixed the inability to not put geometry in and out. Lex is very smart normally, I think he would have sorted that. Anyway, so for the purposes of this video, this would be including the 4 minutes that it took to path the rotary, which took a little bit longer than usual. 18 minutes of user intervention to write the path. Okay. And that's it from me. Cheers, Chris out.